Today we will look at solving single variable equations with the variable on both sides of the equal sign. So let's get started. For this first example, the unknown variable x is on both sides of the equation. But we will continue to use the same techniques we have been using to solve algebraic equations. We will get the variable by itself on one side of the equation with a coefficient of 1. And then everything else will be on the other side. And we will need to keep the equation balanced by performing the same operation on both sides. So one way to solve this equation is to subtract 4x from both sides of the equation. Again, we have to keep it balanced. So what we do to one side, we have to do to the other. So 5x minus 4x, that's 1x, or x, plus 7. And that is equal to, 4x minus 4x, that's 0. So that leaves us with negative 2 on the right side. So we no longer have the variable x on the right side of the equation. Now we have a one-step equation. We have x plus 7, so we'll subtract 7 from both sides, leaving us with x equal to negative 9. Checking our answer, we have 5 times negative 9. So wherever there's an x in the original equation, we'll put a negative 9. And that's equal to 4 times negative 9 minus 2. This is negative 45 plus 7 equal to negative 36 minus 2. Negative 45 plus 7 is negative 38. And negative 36 minus 2 is also negative 38. With this second problem, we have y minus 6 equal to 3y minus 14. For this problem, I will subtract y from both sides of the equation. Y minus y is 0, so we have negative 6 equal to 2y minus 14. So this is now like the two-step equations we were solving in previous lessons. So we'll undo this subtraction of 14 first by adding 14 to both sides. And when we do this, negative 6 plus 14 is 8, equal to 2y. And then we'll divide both sides by 2. And we end up with 4 equal to y. And we can rewrite this as y equal to 4. Checking our answer, we have 4 minus 6 equal to 3 times 4 minus 14. 4 minus 6 is negative 2, and that's equal to 12 minus 14. Bring this negative 2 down again. Negative 2 equal to negative 2. If you notice on this first problem that we did, when I isolated the variable, I isolated on the left side of the equation. But for the second problem, I isolated on the right side of the equation, and then just flipped it when I presented the answer of y equal to 4. On which side should we isolate the variable? It does not matter. So let's do it both ways. So for method 1, we will go ahead and isolate it on the left side. So we have negative 5x plus 10 equal to 2x plus 24. So we want the x to disappear on the right side if we're going to isolate it to the left. So we'll subtract 2x from both sides. We have negative 7x plus 10 equal to 24. Then we'll subtract 10 from both sides. Negative 7x equal to 14. and then divide both sides by -7, leaving the answer of x equal to -2. Now let's do it a second method, and we will isolate the variable on the right side of the equation. So rewriting the equation, we have -5x plus 10 equal to 2x plus 24. So to isolate it on the right side, we need to remove it from the left side. So we're going to add 5x to both sides. -5x plus 5x is 0. So we have 10 equal to 7x plus 24. Next, we'll subtract 24 from both sides. Get -14 equal to 7x. And then dividing both sides by 7. This is -2 equal to x, or x equal to -2. We get the same answer, whether we isolate the variable on the right side or the left side, as long as you do the math correctly. Did we do the math correctly? Let's check our answer. So -5 times -2 plus 10 equal to 2 times -2 plus 24. -5 times -2 is positive 10 plus 10 equal to 2 times -2 is -4 plus 24. 10 plus 10 is 20. -4 plus 24 is also 20. Now for these first two problems, I isolated the variable in such a way that the variable had a positive coefficient. So by collecting my x terms on the left side, for this first problem, I'm left with 1x. For the second problem, by collecting my y terms on the right side, I end up with a positive 2y. So I tend to isolate the variable on the side that's going to give me a positive coefficient in front of the variable. But that's just my preference. If you'd like, you could always isolate the variable on the left side, regardless if the coefficient is positive or negative. Or you could always put it on the right side. So let's practice two more. And again, I will isolate the variable on the side that's going to give a positive coefficient in front of the variable. If I subtract 9x from 13x, it'll be positive 4x. If I go the opposite way and subtract 13x from 9x, that'll be a negative 4x. So isolating the variable on the left side will produce a positive coefficient for x. So I'll subtract 9x from both sides. And this is 4x minus 9 is equal to 3. From there, we will add 9 to both sides, leaving us with 4x equal to 12. And then 4x we will divide by 4, resulting in x equal to 3. Checking the answer, we have 13 times 3 minus 9 is equal to 9 times 3 plus 3. 13 times 3 is 39, so 39 minus 9 equal to 27 plus 3. 39 minus 9 is 30, and 27 plus 3 is also 30. Finally, in this last problem, as a reminder, you want to simplify down each side of the equation first. So in this example, we have the like terms 5y and 2y that we can combine. So this equation becomes 2y plus 2 equal to 7y minus 8. Isolating the y variable on the right side, I will subtract 2y from both sides. This is 2 equal to 5y minus 8. So we're subtracting 8, so to undo that, we will add 8 to both sides, giving us 10 equal to 5y, and then divide both sides by 5. This gives us 2 equal to y, and then we can switch that order and write it as y equal to 2. Checking the answer, again, you go back to the original problem when you check the answer, before any simplification was done. So that's 2 times 2 plus 2 equal to 5 times 2 plus 2 times 2 minus 8. So this is 4 plus 2 equal to 10 plus 4 minus 8. 4 plus 2 is 6, and then 10 plus 4 is 14 minus 8. That is 6 equal to 6, and that's a true statement. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 4 problems. As I solve these problems, I isolated the variable on the side that would result in a positive coefficient. So in this case, I gathered a on the right side of the equation, ending up with a equal to negative 6. In this second problem, the first step I took was to add 5b to both sides, bringing 6b on the left side of the equation, and a 0 on the right side. If you divide anything into 0, the result is 0, so b equal to 0. Just a reminder, although I did not show it here, make sure you are checking your answer by plugging that value back into the original equation as many times as that variable appears in the original equation. So in this case, twice. For this third problem, I solved it by first subtracting 11c from both sides, isolating the c variable on the left side of the equation, resulting in c equal to 6. And finally, for the fourth problem, the first step I took was to combine these like terms. 12d and negative 4d becomes 8d. And then I gathered the variable d on the left side of the equation with a final answer of d equal to 3. Continue practicing solving single variable equations, and I'll see you in the next video.